Good evening. I'm Lisa Friedersdorf. I'm the Deputy Director of the National Nanotechnology Coordination Office, and I'm pleased to welcome you to our webinar. This webinar is part of a series that support the Teaching Nano and Emerging Technologies Network. This network was formed so that teachers could facilitate interactions between teachers, share best practices, exchange ideas, activities, and examples, facilitate access to classroom-ready resources, promote local area events, and connect with each other across the country. On this slide, you'll see a number of links, and I encourage you to go to nano.gov and look for more information about nanotechnology and about this teachers network. This webinar series is archived on NanoTube, the NNI's YouTube channel, and I'd also like to draw your attention to a resource portal that has a number of resources for teaching nanotechnology. Tonight's topic is remotely accessible instruments for nanotechnology. And to introduce this topic, I would like to introduce Bob Ehrman, Managing Director of the NAC Center at Penn State. And he will begin with an overview of NAC and RAIN. Bob?
Thank you, Lisa. And first, I really want to be, on behalf of all of our presenters tonight, thank you very much for taking time out of your precious home time to attend this webinar this evening. As Lisa said, the title of this webinar is An Introduction to Remotely Accessible Instruments for Nanotechnology. So, I'm going to start with presenting or introducing our presenters. You'll be hearing from them later in the presentation. And I'm going to do that a little bit differently. I'm going to introduce them via the weather report in each of the places where they are. Lisa was in Arlington, Virginia, and the weather there is, according to AccuWeather.com, 66 and cloudy. Jared is in Pasadena, and where it's 74 and sunny, and the kind of the tune "It Never Rains in California" comes to mind. Mike Lasicki is actually let me go back and introduce Christine as she's the center director for the SHINE, which is Seattle's hub for industry-driven nanotechnology education. Mike is actually the director of the Maricopa Advanced Technology Education Center in Mesa, Arizona. So we kind of call him Mesa Mike sometimes. And Mike is, the weather there is 85 and sunny. I'm here in State College. As Lisa said, I'm the managing director of what's known as the NAC Center, and I'll talk a little bit more about that on the next slide. And here it's about 64 degrees with a mixture of clouds and sun. And I saved Seattle for the last because according to AccuWeather, it's 60 degrees there and rain. So Christine is the one who's carrying on the tradition of rain. Hopefully tonight you'll hear how our collective efforts and what we call RAIN, or Remotely Accessible Instruments for Nanotechnology, are storming across the nation. Okay, so I want to pause here to give credit to the NSF, without whose support, none of what you would hear tonight would be possible. Many of us are supported by the NSF. For instance, I'm the managing director of what's known as the NAC Support Center, which is the Nanotechnology Applications and Career Knowledge Center. It is focused on nanotechnology workforce education. I'm here at Penn State University, and we work with community and technical colleges in Pennsylvania as well as across the country, as well as K-12 educators, which I believe we have a lot in the audience tonight. One of our roles is to help nanotechnology, help to infuse nanotechnology into classrooms across the country. Again, primarily focused at the community college, technical college level, but also into the K-12 level. So we want to create a nano-literate population and to excite students and teachers to the incredible possibilities that work at the nanoscale for workforce at all levels, from PhD scientists to technician hold. Many years ago, we had a vision to bring the nanoscale directly into classrooms via our nanoscale instruments that we had available here at Penn State. and through the program that that was the genesis of this center in Pennsylvania, and to allow remote participants to see the nanoscale and remotely control our instruments. This page is one of our advertisements showing that our vision is now being realized and is still a work in progress, and that you can indeed bring the nanoscale into your classroom. We're going to talk a lot more about this later on how to do that. So the agenda today is I will, and I have started to, talk about engaging your students' RAIN on their world, the NAC Support Center RAIN initiative. Talk a little bit about that, what it is. And Christine is going to show you how it's done. She's going to give some examples and how it rains in Seattle. Mike is going to show how you can make it rain, how you can bring it into your classroom, how to kind of the mechanics of how things happen, and kind of some feedback that we've had so far. And then Jarrett will rain on you. He'll give you a live demo. And I take no credit for any of these titles. They were out of the creative mind of Dr. Michael Lisicki from, or otherwise known as Mesa Mike. Okay. So what is this remotely accessible instruments for nanotechnology? It's basically, it's a way to connect, you now have the ability to connect your classroom to equipment in labs across the country via simple distance technology tools. Mike will be talking about the mechanics of this later, and he'll show us how to get there via our website, okay? So what's our mission? We want to create a lower barrier to entry to high-tech scientific equipment. Each of the RAIN partners have different pieces of equipment. Some of them are the same, but we want to bring those into your classrooms. We want to enable you to deliver relevant educational activities for your students interested in learning about nanotechnology in particular and other STEM fields in general. So we really want to keep those students in STEM, and we're hoping that this is one vehicle that will help to bring them. We want them to be the next workforce, like I said, from anywhere from technicians, technologists, engineers, educators, scientists, and we want to engage them and with tools and also with experts. I think that's a great way to connect to some of the people who are doing the real work, and some of their stories are great on how they got to where they are. Okay. By the way, there's going to be some questions. We are going to have some question break in a couple of minutes to be able to answer questions. So please enter questions if you have them. You can type them in, and then we'll be talking about them later. Cool. So here, the resources that are available, we have a multitude of resources available, and you'll see those later. But we want to provide remote access to these sophisticated tools, and we want to provide these educational opportunities to learners who would normally be isolated geographically and or financially from these resources. So we have a whole raft of tools, which you'll hear about in a couple minutes. This remote access, and I really could title it remote access and control. It's not just watching somebody do the work. It's actually, you are actually able to you and or your students, preferably your students, are able to control the instruments remotely. And I think that's really kind of a key element where they can really get some hands-on. But you can use it for an outreach experience, or a workshop or webinar demonstrations, as we're doing today. We're going to show, later on in the presentation, we're going to do a live demonstration. For class demonstrations, just for a whole class, if you wanted to do a demonstration for your whole class. You may have equipment at your school right now. You may be blessed with some really great equipment, and I know there's some schools are, but you might have an atomic force microscope, but you might want to compare it with a scanning electron microscope or something at one of your partners or one of your institutions in your area or anywhere across the nation. You could do that to supplement your own equipment. Or you might want to assign your students to do some work. We typically do that at the community technical college level, to actually do a lab and then report back the results. So lots of, there's a whole range of activities that you can actually do utilizing remote access. So I mentioned there's a whole set of tools available. You can, all these tools, you don't have to you don't have to take notes because they're available via our website. Mike will be talking about the website later, but you can see it up there. Hint, hint, it's www.nanoforme.org. You can actually, see things like, we have things available like scanning electron microscopes, EDSs or energy dispersive spectroscopy to get chemical analysis, AFMs, profilometers, UV-vis spectrophotometers, and confocal microscopes and optical microscopes. And I think we're going to see a couple of them later on when Jared does his demonstration. You also, we also have via the website in remote ready labs. You could choose to actually just say, I want to look at some hair, I want to look at do some samples, and I believe Christine is doing that later. Or you might want to say, I want to do a lab and then actually use one of your own laboratories or one of the growing list of laboratories that you could perform that we actually have on our website. You can analyze the results. You could do the lab in your classroom and then analyze the results using the remote tools at one of the nationwide RAIN sites. You may have a great idea for a lab that could be added, and we welcome these additions and would love to have you add these to our library so that others across the nation could share them and utilize them. A vision is to have a very large library of inexpensive labs from all across the U.S. added to our site. Okay, so we provide the background, procedures to these labs. The students will qualitatively analyze them in your classroom, and then we quantitatively analyze them together. So now I'm going to show you this map here illustrates actually 9 of our 10 RAIN partners. We now just recently, within the last couple of days, added another site. We added UTSA in Texas, University of Texas at San Antonio. And I'll go around the country and I'll tell you who we have available. We have in North Carolina, we have Forsyth Technical College. We have us at Penn State. We have Rich at Erie Community College and in Williamsville, New York. We have John at Oakton Community College in Chicago area. We have Frank at North Central Tech in Wisconsin. We have Jim at Salt Lake Community College, obviously in Salt Lake. We have Ray at Arizona State University, very close to Mike in let's see, Scott, I don't know it's in Phoenix area, let's put it that way. We have Jared, who you'll be hearing from later, in Pasadena. And we have Christine in Northern California. And actually our RAIN is kind of growing. RAIN network is growing. We have a bunch more that are actually coming, will be coming on board hopefully in the next 6 months to a year. So with that, I'm going to now introduce Christine and let her take it from here and talk to you about how it rains in Seattle and give you a little bit of some ideas of how her experience. So Christine?
Thanks, Bob. Thanks for the introduction earlier, and like you said, it's very fitting today. It did decide to rain today. It doesn't rain every day in Seattle, but it decided to rain today for this webinar, so that's very fitting. So to give you a little bit of a background about who we serve the Pacific Northwest region, that's Oregon, Washington, and Idaho, and we help bring nanoscience and nanotechnology into the classroom and help educate students and teachers with the skills they need, as well as training students for the workforce. And part of that, of what we have and what we support, is a nanotechnology program at North Seattle College in Seattle, Washington, and a nanotechnology lab, which we use for RAIN activities. So to give you an idea of what we can do and how we can help bring those RAIN activities into the classroom, Bob alluded to some of these things or touched on some of these things, but I wanted to emphasize the things that we've done in the classroom. So what we can help you do is tailor an experience to your class or your event needs. And so you might have an idea, you might be talking about something going on in your class and you're not exactly sure what you want to do. And so you can reach out to the RAIN network and one of the sites, and maybe you know some of the teachers that are involved or one of the centers involved, and so you can reach out to them and have a dialogue going to create something for you. You might have a lab, or you might use one of the remote access labs and use that to supplement something you're already doing in the classroom. So that's a great way. Something that we like to also do with a lot of our participants is actually having students collect samples and send that in to us. And many of our sites do that too. So it really engages the students and brings a personal level into what they're doing. Like the picture you see here on the screen, this was actually a professional development opportunity that teachers wanted to understand how remote access worked and understand more about nanotechnology. So this was us hosting a professional development event. And then lastly, an outreach event. You might have a STEM fair or just a general activity with your school, and so we can do that for you as well. And so to give you an idea, like Bob said, of what type of activities we can do, I wanted to start with some of our most basic activity. And this is what I like to call the what is it game. So maybe you don't have a lab in mind or a specific topic that you want to talk about, but you want to bring nanotechnology into the classroom just so students have an idea of what it's about. So why don't we go ahead and get some audience participation. We probably won't address every image for the sake of time, but let's start with the image on the upper right. If you have an idea of what that is, go ahead and type it into the box. So what do you think the upper right image is? Oh, I got some good answers right off the bat. We have pollen. Now that, it looks like everyone's getting it, so it is pollen. So I usually like to ask the next question, well, what type of pollen do you think it is? So this is what usually happens. Students are just like, I don't know. They might not have any idea, and then I'll help probe them in and say, well, people, you might see a commercial about this. You might see this, people suffer with it on a seasonal basis, and so those are the types of things that we talk to. So I'll go ahead and let you know it's actually a dahlia pollen. So not a lot of people know what dahlia is. It's a beautiful flower, and then I'll usually even post up a picture of that too so they can get an idea. And so maybe let's go ahead and go to the bottom right, and what do you think that is? Go ahead and enter in your answers in the chat box. Okay, I got a couple answers. We got spore, we got a blood cell. Any other answers? You can see there's also, and you'll see this on your screen, you'll get a sense of scale. If you see the scale bar, that's 2 micrometers. Got more pollen. Okay, I'll go ahead and answer it. And so, yes, it is more pollen. So it is a different kind of pollen, and so that also gives you a sense of look at the variety of pollen. And so I'll also ask what type of pollen it is, but it is pollen that comes from a lily. So it gives you this nice idea of how things can vary so differently, and why some things maybe grow differently, affect people differently, and things like that. So I think I'm going to go ahead and move forward, but I'll let you know, just in case you're wondering what the other two images are. On the upper left, we have a moth wing, and on the bottom left, we have an ant-eye. So, and all of these were captured remotely. So if you would like to take a step further and have a little bit more of a structured lab. This is an activity that we did with a high school that's fairly close to us in Bellevue, Washington, at Newport High School. And this is an example of them contacting us and saying, we want to do a forensics activity, but I'm not exactly sure what I want to do. And we bounced around ideas, and then we said, hey, yeah, we can go ahead and do a hair forensics activity, because this is very common actually in crime labs. You know, they use scanning electron microscopes, and sorry I didn't mention it before, but those previous images are scanning electron microscope images. And you know, the types of different things that you see about hair or fibers, and how you might address those differences. And so what we did was we collected several samples, and you'll see here that they are of varied width, and come from different people and have different things on their surface. And then we also had a specific crime scene hair. And so we had the students, or one student for each sample. We actually had a couple more samples, and they would drive the instrument. And then the students would make notes about it. They would measure it across like you see now and notate any differences from sample to sample, and then look at the crime scene sample and see if they could match it up with the different suspects. And so you'll see it varies widely. Some of them, we've got about 60 micrometers up to 95 micrometers, and then we have a really small one, about 17 micrometers, and so it does look distinctly different. And maybe we can get another. I like to have the audience answer. Do you know, is there any difference between that sample that is about 17 micrometers? Why does it look so different if this is hair? See some chats going. I'll wait a minute. Age of the person. We got animal hair. Great. Different part of the body. Oh, yeah. So those are great answers, and those are some of the things why you see differences. If someone colors their hair, age does seem to affect width, ethnicity does. And I saw one that said a different type of hair and animal hair, and it was animal hair that comes from a cat. So you'll usually see human hair ranging somewhere between 50 and 150 micrometers, and then maybe animal hair under 30 micrometers in width, and it looks distinctly different. So this is a type of activity, and usually I also like to pop up the cat and maybe the people that it comes from too. So it gives you a sense of the differences, and I'll go further to maybe a more involved type of analysis. And so Bob talked about EDS, energy dispersive X-ray spectroscopy, and this is a form of chemical analysis, and a lot of our scanning electron microscopes have this feature where you can look at the sample and you could also get chemical composition as well. So the sample that you're seeing right now is a fractured stainless steel sample. So it was broken, and on the upper right, it's in a type of mode where you can really see the surface characteristics. You see like the striations and just the mechanical disruption that happens when you fracture it. On the bottom, you see different contrasts, and this is a mode where you can get qualitative data or qualitative information based on the size of the nucleus of your elements. And you can talk about theory and go further into that, and we can help you with some of that theory. And then on the right is actually the spectroscopy. So you get a spectrum of the materials that you find in the sample itself, and on the top is some of the lighter areas, and so you see chromium and iron and nickel and aluminum, which are commonly found in stainless steel, and you'll get maybe different quantities depending on the type of stainless steel. And then we probed the dark spot, that's the spectrum on the bottom, and it had mostly aluminum. And so one thing that I didn't mention is this was an aluminum coated stainless steel sample, and when it broke, little flakes got into that, and you couldn't really tell until you went under the microscope, or you weren't able to notice that. So when I talk about students sending in samples, maybe you're doing a type of research experiment, and we've had some students send in samples and looking at how well they may have fabricated something, and maybe why something looks different or acts different, and so they send in their samples and then spend some time studying that. Okay, and the last thing I wanted to address are things that can go wrong, because as you know, technology doesn't always want to play nice, and things will go wrong even if you've tested it out. But I do want to state that the test session is crucial, so Mike will talk about some of the logistics in the process. And I want to emphasize having a test session before the day of your live session is very important, because audio and video issues, connection issues happen, which takes me to the next step is try to have an alternative for remote access. Whether we use a program called Zoom, there's other things like Google Remote Desktop and Team Viewer, so maybe having an alternative as well as an alternative audio method. That seems to be the thing that trips up the situation mostly is audio, and it's hard to have a really good experience without some audio. And so I've had teachers just call in on their cell phone or on the landline phone or use Skype in addition to the remote access software. So, and lastly, samples that don't work well, if it's too smooth and it's the same composition throughout, it doesn't really look as great on something like a scanning electron microscope. Also, if you're collecting samples, if it's too dirty, like has a lot of dirt, unless you want to look at the dirt, sometimes that may not go too well. And we haven't had anyone send in live samples, but I have had people using our lab give us live samples. So we would appreciate that your samples are dead before you mail them off or send them off, because they do need to be dead, and we would prefer not to have to kill them for you. So, and then this is an image also I wanted to point out. On the right, it is used with our confocal microscope, and was captured actually by one of our students, and it's a biofuel producing algae that autofluoresces. So you can get some nice images with biological samples here. So before we go on with the presentation, I'd like to take a break now and ask if there are any questions from the audience.
Hi, this is Lisa. There's been a number of questions that have been put forward into the chat box. So I think that there's a number of presenters who are trying to quickly answer those questions. But one thing that has come up in preparation for this meeting was a question about managing the classroom. So if there is a number of students in the room and you're going through this remote control of the instrumentation, how do you really manage the full classroom of students?
Sure, and I guess I'll go ahead and take that, and Bob, feel free to chime in also. So a couple of ways, or several ways. One that we didn't mention is I usually like to have a video feed. So we have a webcam on our end, and so if you also have a webcam in your classroom, that's great, because we can see each other, and there's really that personal connection, and it's a way to feel like we're both in each other's labs or in each other's classrooms. So that really helps with managing that way. Also, we try to have a long enough period where several students can actually run the instruments, and so if you have about an hour, you might get 7 to 10 students being able to run the instrument, so it gets everybody on there. Also, another way with this software is if you have a lab or a classroom or students with laptops, they can all log in. And so it isn't one person having to just look at a monitor. Usually we like to have the session projected so everyone can see it on a large screen, but it's also great if you can have multiple students logging into several computers and doing that. I did want to give an example, touching base back on the forensics lab, to make sure, because it was a classroom of about 32 students, and it was only about 7 students that ran the instrument, is we created handouts to give the instructors, or to give the instructor to hand out to their students so they could read up on the activity, and then it had spots for the students to draw the samples or draw what they saw, make notes, and so that really allowed them to be engaged and helped with management of the classroom, so everyone felt like they were involved. Does that answer your question?
Great. I'm going to address a couple of the questions.
Can,
Sorry, I'm going to jump in. Just
no problem.
some of the questions regarding safe handling of nanomaterials. I just wanted to point out on nano.gov, there are some resources that have been developed by some of the agencies that participate in the NNI regarding safe handling of nanomaterials. We also had a recent webinar that focused on laboratory procedures and safe handling, and I would point you to those resources. I think that if you have specific questions, we can address those as they come up. But in general, that's a great starting point to really look at the resources that are available, because the materials do behave differently at this scale, and it's important to be aware of that. So I'll turn it over to whoever else was trying to jump in.
Yeah, that was me. I'm sorry, Lisa. I wanted to just address one of the questions that was asked about going to multiple customers, if you will, for the remote access. We now have a program called Zoom that we're using at many of our sites, and it actually we can actually have up to 50 different people on at one time. We haven't tested that far yet, but I saw that the one school does this through distance technology, so we can actually have those students that Christine was talking about we could give control right at their laptops if we wanted to each one of them, and then the person at the instrument has the ability to give control to Susie or Sally or Joe or Javier or whoever across the classroom all at one, and give them control, which I think makes it kind of cool. So I wanted to address that question, Lisa.
Great. I wanted to toss out to all of you with RAIN. There was the first question in the box was referring to the possibility of doing a field trip. Would anyone like to respond to that?
Yeah, actually, I can only speak for myself. I can't speak for all the RAIN partners. I'm not sure what their policies are, but we welcome that, especially we would like to draw students into either our community college, technical college partners across, who we service through our program here at Penn State, or into the program at Penn State. So we've done a number of we do field trips all the time. Let's put it that way. So I'm not sure, Christine, you can chime in on this, and others, maybe Jared can later on.
Sure, yeah, and exactly, Bob. We do it as well. We do several field trips. Usually it's nice if if the class is there for at least 2 hours, and they could learn several of the instruments and learn how to prepare samples and get a little introduction into the program, as well as more information about nanotechnology. So we love it when classes come into the lab.
Okay, I'm going to jump in. We will have some time for questions at the end. I also wanted to point out that we will be sending out some resources based on some of the conversations here today, like a point to some of the safe handling procedures. Also, I'm seeing a lot of back and forth in the chat box about particular labs and resources. We'd love to capture those and make sure that they are shared among this teacher network. This is exactly the reason we have this network, so you can learn from each other. But with that, I'd like to turn it over to Mike, and he'll talk a little bit more about the process to sign up for RAIN.
Thank you very much, Lisa. I represent that node down there in the Phoenix area, and by the way, I wanted to remind you that in Arizona, the words river, wash, lake are not associated with water. I thought I would just throw that in there. So as Bob was mentioning, there are partners across the country, and you're thinking, well, if I'm going to make this connection, do I have to choose my partner? Do I have to choose the site? You can, if you like, or you can submit your request for a session and then we'll choose that based on availability. So either way. How does this work? As a person requesting access, your RAIN partner is going to set up the instrument with samples for your classroom to view. Now, it either can be samples they have on site, or as we just discussed, samples that you'll send in. Now, your classroom computer is going to connect for full control of that instrument. That means your students are actually going to be using their mouse to drive the instrument. They do this in real time, so it's pretty exciting. Here's an example of a remote classroom session. Christine mentioned using a large projected screen. That can work. You can see the students sitting in the audience. You can tell they're actually very connected to the presentation. Most of them have their heads down looking at their phones. No, I'm just making a joke about that, but I happened to notice that as I was looking at this diagram. But by projecting it, it really does help engage the students more. All of you teachers know how to use strategies to help engage students during sessions like this one. So what do you need? You're sitting there thinking at your computer tonight, you know, I might be willing to try this. How hard is it going to be? Well, you need an internet-connected computer, no problem, because everyone has that, with administrator access to install Zoom. Now, there's the only potential point. Most of the classrooms here in Arizona will not have a problem installing video conferencing software. You probably want to check with your IT administrators. It's a straightforward thing to do. It's cloud running software. It's pretty, you're essentially installing a local application of it. Speakers and microphones are important, but all of you have those in your classrooms, and everybody today, it seems, has a projector or a large display. I like Christine's suggestion of having the students using their own devices, laptops. I'm not sure about iPads. I guess that's a question I have for myself. But I think there's many ways that you can encourage your students to join in the viewing. And in other words, you're trying to increase their engagement. Okay, so now you're excited. You want to do this. How do you request the session? You go to Nano for Me Remote Access. And a bunch of stuff on that page, but there's a form there. You fill out this brief form. You'll get an answer within 24 hours that will confirm your session. Either you've requested a specific partner or we'll assign you one. And Christine mentioned that test session. That's critical, so they'll set that up. Test session probably takes 15 or 20 minutes, not too much time to make sure that everything is working. That's going to ensure that everything is in place. And here's my comment. I added this one here. Use the same equipment in the test session that you plan to use in your classroom session. I know that seems obvious, and you would think today, well, how much difference could it make? It can, so make sure that you're using that same equipment. Back to maximizing engagement. There's been a lot of chat about labs available. There are 4 labs available on nanoforme.org/remote access. So those are recommended because you're engaging your student, right? They're creating the samples themselves. They'll be looking actually at their samples during the remote session. And as I say, there was more conversation in the chat window about exchanging information about labs. At the minimum, there's the NAC video on the particular piece of equipment that you might have. So you can see those on the website. There's some tutorials on atomic force microscopy, scanning electron microscopy, other things like that. So you want to prep your students, right? You want to give them a chance for them to review those things, bring them back in the classroom, fire some questions at them, make sure that they've had a chance to look at it. And again, to maximize engagement, you teachers, keep your hands off the stuff. Let your students run it. You know how they'll like doing that. Besides, they'll probably be better. They would be better than me doing it, that's for sure. On the day of the remote session, did I say this before? Yes, use the same equipment you used in your test session. And it's a good idea to connect about 15 minutes prior. Now, a lot of you have, say, 45 or 55-minute periods or whatever the timing is, so you'll have to work the timing a little bit. But by having that 15 minutes ready to go, you'll be there. Turn your eyes to the lower right of this frame. Remember when Christine said that the students can use their laptops or their devices to log in? You can see them doing it right there while they're looking at the projected screen as well. So there's a good example of I think, a pretty good classroom engagement that's occurring right there in that remote session. Don't forget step number 1. Go to nanoforme.org/remote access. There's a whole bunch of stuff there, a lot of imagery. You can see what equipment is available. You can see where it's located. And by the way, did we mention this is all free? Well, of course, the National Science Foundation is paying for it, but there's no charge to any of the participants that are taking part in RAIN. So thank you, NSF. And now we're ready. We're actually going to go live. We're going to ask Kristen if she could activate the screen sharing to our remote site. Here we go. Jared, would you come on with your audio, please?
Okay. Hey, Mike. How you doing?
Oh, good, Jared. Your audio sounds really good. Let me introduce you. You're calling in from Pasadena City College.
Yeah, I'm in Pasadena, and it's beautiful weather here.
And I didn't realize that your background is chemistry, so you're a chemistry guy.
Yeah, I'm a chemistry teacher at Pasadena City College.
All right. Very cool. So you're going to let me run the equipment today, and tell me about the sample that you've got prepared for us. Remember, there's a whole bunch of teachers from around the country that are watching our every mood, and this is actually live, so I hope I don't make a mistake.
All right. So I got a sample from my dean, who's a geologist, and they are marine fossils that are basically calcium carbonate and magnesium carbonate. I think they're called Dixons. But if you want, right now we're looking at an optical image of the marine fossil, and if you could hit the button on the right where you see the little cross.
Oh, I see it there. Yeah, I see it. Okay, I'll hit it.
To the scanning electron microscope. All right, good job.
Okay, here we go.
It does take a little bit of time to load the scanning electron microscope. So.
Oh, I see the progress bar there. Yeah.
Progress. I bet you have a great joke.
You mean in addition to my Arizona water jokes?
Yeah, all right, so the progress bar.
I'll save my jokes. It's coming up too fast. I'll have to save my jokes.
All right. And I know someone asked about water samples earlier. The samples for our SEM do have to be dry samples since it's in a vacuum. You cannot put samples that are not dry into our SEM.
Oh God, that looks like an asteroid. That's an asteroid.
I wish it was an asteroid. This is actually what a marine fossil looks up close, the little holes in it, and there's probably some diatoms that are inside of those little holes. But if you would like to get closer, you could go down.
Oh, yes.
Yeah, do you see the buttons that are down on the right-hand side?
Oh, the lower right, yeah.
Lower right,
yeah.
And there's one that's in a green with a little crosshair. If you move the crosshair over to that
like
button,
that?
Yeah.
Okay, good.
If you put the crosshair there, it's easiest to do with a rolling mouse, because if you now move your roller up, then
I got the roller. Yeah.
Yeah. So if you move the roller up, that's going to magnify it.
So there we go. Oh, look at that.
Yeah. So nice. Now, once you magnify it, you might have to go and get it more into focus. And if you look right underneath where the magnification button is, you have two different buttons. One of them has a little oval. If you move it down to that little oval, then you click on it. Where it says A, one of the nice features of our SEM is that it'll actually do autofocus for you. Which
here we go.
Yeah, for remote access, this is really nice because sometimes what happens is that if you get a student up there trying to focus a long time, it sort of distracts. So we got a nice autofocus that allows it, just hit the button once and it'll focus for you.
Those are nice and sharp. Yeah.
And right now we're only at 590 times magnification. If you look down below the image, you can see what magnification that you were at. You can also look and see where it says the 10 kilovolts. That is the amount of electrons that they're basically hitting the sample with to get the image. And there's also the ruler there that tells you how big the sample is.
100 microns. I see that there on the lower left. Yeah.
You could also go up, and you see the button right above the focus that has the A that has a little light ball
Yes.
that's a circle. That's the brightness and contrast. So go ahead and hit that button.
Okay, I hit it.
And this will basically do an auto brightness and auto contrast image. So what would you like to do with it, Mike? Would you want to zoom in, zoom out?
I want to magnify this baby up. I want to look closer.
All right, so go ahead and put the cursor back on the green square and just roll your mouse roller in the up direction, and that's going to magnify it. Is there a value that you'd like to go up to?
If I could get down to less than 10 microns on that scale, I'd be happy.
All right,
it's 30 now.
It's 30, yeah, so just keep on rolling it until you
Okay.
get down to 10 microns. One thing you do have to be a little bit
Scary.
careful. It's scary. One thing you do have to be a little bit careful of with a big sample is that if you get too close, you lose a lot of the image in the sample. So
Right.
let's go back
Right.
down and focus it again. So move the cursor
Okay.
down to the oval. We're going to focus it. We'll do an autofocus again. Sometimes if we get too close, we have to focus it manually, and it ends up taking more time. So for remote access, and then you can do the brightness and contrast right above it.
That's
again.
better. Yeah.
So sometimes for the remote access, one thing that you can do is think of what samples you want to look at, and then talk to us about what would be the best way to image it. Because as you can see, we've probably gotten a little bit too close to our fossil sample, and that's why you're kind of getting the blurry image.
Sure.
We could go around and try and focus it ourselves, but if you're in a class and you have 30 people, you are going to have a really big projector and project it on the screen, hopefully to keep everyone engaged, but it still would take a little bit of time for the students to focus it, and I've seen it where people just get frustrated and you lose the students. So in this case, I would probably, for the remote access session, not want to go up to 4400 magnification.
Let me back up a little bit. Let's go back to like 30 because I have a question for you. Once I get back there, let's see. Move it over to the magnifier. Now, click roll. I got a roller. Okay.
Remember, don't roll it up. I know you're rolling it up right now. Remember, that's magnification. Roll it down.
Oh yeah.
to magnify.
Okay. Sorry. Sorry. There we go.
All right, so now we're at 30. Let's go down really quick and just focus it again. So
yeah. Okay.
Button.
Right there. Yeah. Oh, cool. This is cool. While that focus is coming up, oh, that looks sharp. You may not have it active today, but I was using one of these SEMs one time, and they had like a measuring tool on it. Is that an option? We don't have to do it today. I don't think we'll have time.
Yes, we do have a measuring option. You would save the image, and then you would bring up a ruler, and you could actually pick 2 points, and it'll measure from each of the points. Another feature that we actually have, and I know a lot of the sites around the country have, is what's called electron dispersive spectroscopy, EDS.
Yes.
And that'll allow you to do elemental analysis. So if you did want to do elemental analysis, it would take us probably about 5 minutes, and we would just convert to that device, and then we could do elemental analysis of the fossil.
Well, Jared, in the interest of time, I know it's late in the evening for many of our teachers. This has just been fascinating. You've convinced me. I've got a group of a couple of students in my materials science class here. I know it's Course Community College, but I know they're welcome as well in the RAIN world. I want to prepare some samples and have them do it. I really like this. I appreciate your help, Jared, with this today. It's been great talking to you live. So thank you.
Yeah, thanks, Mike.
Kristen, will you take us back, stop Jared's sharing and take me back? Oh, perfect, perfect. Colleagues, you've seen how this worked. We're actually doing this live. I got to control the scanning electron microscope sitting right here at my computer, so that was cool. Let's open the floor now. Lisa, back to you and see if there might be questions. There's a bunch of chat activity here. Are there specific questions you'd like to bring forward to any of our presenters?
I saw one earlier that I'm not sure if I saw an answer. It's the chat box is moving so quickly. So there was a question about looking at soft materials or wet samples, and I know that requires an environmental SEM, and the one that we just saw demonstrated requires a vacuum, and that was not possible. Are there instruments in the RAIN network that that you can look at wet or soft samples?
Let's turn that to Christine.
So our SEM doesn't do, we don't have an environmental SEM, so it does need to be dry also. But we do have a confocal, like I said, a laser scanning confocal microscope, and that you can use biological samples or samples that fluoresce or samples that you can dye to fluoresce. And you can do live samples in there also. We've had people do live samples. It doesn't get down to the nanoscale necessarily, but you can look at things like bacteria, cells, things like that. So you might be able to see some features, and it does use technology, nanotechnology, but you will not be able to see features or resolve features on the nanoscale like the scanning electron microscope. But you can take time-lapse video. So if you're looking at live samples and you want to see some kind of process. We've never done that remotely, but we'd be happy to try that out with somebody or someone or a teacher that's curious to see how it would work.
Lisa, can I address that a little bit? Not exactly directly answering your question. We're constantly adding new instruments onto the site, and one of the things, it's not biological samples, but we are adding a transmission electron microscope in the near future. Salt Lake Community College has one, a TEM that they have just purchased and are just bringing online. So that's pretty exciting. We'll have a new tool in our tool set.
Great. Bob, did you have any other questions that you saw in the list or others that you wanted to address?
No, there was some. One of them was on the technology, Mike, about the Zoom versus TeamViewer, and there we do have the options of using both. And we're right now where some sites have been using TeamViewer, some have been using Zoom. We were able to use some NSF money to purchase a multiple license for an upgraded Zoom. So we're using that. That enables us to do some longer sessions and also multiple people at one time. So we're moving towards that, but not precluding TeamViewer. As Christina, I think, talked about earlier, we can do it via multiple media. We're just, there are different ways to skin this cat. We're just choosing to go with the Zoom because we happen to have that, bought the license, and it seems to be working very well with us. We've gone through here at Penn State probably 4 or 5 different programs to try to come to this right now.
Bob, also there was a question. You could tell we were promoting the idea of individual students within a RAIN session connecting via their laptops to increase engagement. And the little catch there is that you've got to install that viewer on their machines too. But one thing that students do is, and they know how to download stuff to their devices today, especially apps and stuff. I bet you if there isn't any IT issues in the classroom, that's not going to be a hard challenge to overcome. But yes, each laptop participating or device needs that viewer installed. Absolutely. Now we're also increasing here on the RAIN site some more information about overcoming any potential firewalls you have, some ideas for that. So we're trying, always being aware of that potential technology challenge. So you'll see some more things, Bob, coming up on nanoforme.org/remote access pretty soon about that.
Fantastic. Hey, Mike, I did want to address another thing that you mentioned earlier about, you can go anywhere in the country to access a RAIN site, and that is indeed true. However, one of the things, the reason we're trying to grow this network is that it's our belief that having like a RAIN site close to the classrooms they service will show the students that opportunities available right there in their backyard, perhaps at a community college. We just did one too. We just did 2. We just saw 2, Pasadena City College and North Seattle College. So this is not just for the future PhD, it's for your whole spectrum of students within your classroom. And you don't have to address a research 1 halfway across the country. You can hopefully will be able to, in the near future, be able to bring these RAIN sites all around the country because many people do have equipment that they are willing to share. I just wanted to make
Bob,
that extra.
That's a great comment, and that's a perfect segue as we wrap up our session. Lisa, I'm going to turn the control back over to you. I'm going to advance one more and ask you to talk to us about National Nanotechnology Day.
Yes, absolutely. And I just wanted to reiterate that we will be sending out some additional information. I think that there's still some questions that we didn't quite get to address, including some questions about sample preparation, and there's resources being shared about how an SEM works, and I think that these are things that we'll capture and send out to you and also make available when we post this webinar for archival purposes. I wanted to let you all know that we're very excited about National Nanotechnology Day, which is coming up this Sunday. It is October 9th, of course, for 10 to the minus 9. And this is the first year, and we expect this to be an annual celebration of nanotechnology. And the intent is to raise awareness of nanotechnology and also to showcase the many things that are happening all across the country. And we've been collecting information from folks when we hear about what they're doing, and we will be sharing that on nano.gov. So if you have plans to do an activity or an event on or around, since it is a Sunday, it's not a single day, this is kind of a drawn-out celebration of nanotechnology, we really would love to hear from you, and the address is there on the website. And one of the activities that we are aware of is the RAIN open house. And Bob, did you want to comment on the open house you have planned?
Oh, we are super excited about this, Lisa. We have 9 of our 10 sites participating in this, and it's actually going to be a concurrent activity that will occur actually not on October 9th, because unfortunately 10/9, 10 to the 9th this year falls on a Sunday. So we were a little worried about having an open house for RAIN on a Sunday, so we moved to Pico Day. Well, it's not really Pico Day. 10 to the 12th, October 12th, and we're doing it concurrently at 1 to 3 p.m. Eastern Time at 9 of our locations across the country. And you can actually access that you can see the website there, nanoforme.org/RAIN open house, and there's a lot of information on that. And 9 of our 10 sites, our present sites, are participating in that. You can either call in to the number there, and they'll put you onto a site, or there's actually an advanced registration at that website to be able to access this. And you can come and go as you please. You don't have to stay for the entire 2-hour period. You can come in and join it, and using the Zoom technology actually be one of the participants. So it's really exciting. I hope that many of you will take advantage of this activity.
I'm very excited about this, Bob. I'm really thrilled, and we're glad to highlight this as one of the many activities that we hope to hear about happening in celebration of National Nanotechnology Day. One of the things that we're promoting is kind of mixing a little bit of activity with raising awareness, and that is to encourage people to share with us how fast they can run 100 billion nanometers. So we're hoping that folks will do the 100 million nanometer dash and use the hashtag that's listed here on this flyer, and really get students to start thinking about, how far is that, and how long would that take, and to share their videos and their pictures. So you're welcome to download this flyer from nano.gov and share it with your networks, your teachers, your students, and we have gotten a lot of excitement about this, so we're anxious to see how far this really takes off this year. I wanted to also point out that some of you may be aware of the Generation Nano contest, which was held last year. This was something that got a lot of attention, and Stan Lee actually helped to promote this last year. and NSF will be relaunching the contest for high school students this week as part of the celebration for National Nanotechnology Day. And more information will be available at the nsf.gov Gen Nano site and also, of course, on nano.gov. One more click. So Bob, this one's yours.
Oh yeah, I'd just like to thank everyone. We've had a team over the years that have actually participated in the creation of this, and it's really been a long journey to get where we are today. So this is actually a depiction of the team. That's the many people from across the country over the years who have helped us create this RAIN network. So it really takes a team to create has taken a team to create this network, and it's all about the people that have created it and all about the people who have been using it and you, the future people who will be using it. So thank you all.
Great, thank you, Bob. And with that, we're at the end of our hour, and I would like to thank our presenters. I think that was absolutely fabulous to share the RAIN network. We're really excited by the capabilities that you're continuing to expand and will help, you know, raise awareness and try to draw people to your network to share these really amazing tools. I'd also like to encourage folks to join the Teaching Nano and Emerging Technologies network if they're interested. You're welcome to email nanoed@nnco.nano.gov to learn more and to get connected with the other teachers. And with that, I'll thank you and wish you all a good evening.